Welcome to session 5. You'll remember from last class that this folder and the subsidiaries are effectively the web page that we send to clients via this line here in the server. Now, let's actually start looking into these files. Here's an HTML boilerplate. Notice these connected endpoints, profilepage.css and profilepage.js. As for profilepage.css and profilepage.js themselves, we can leave them blank for now with no boilerplate. HTML is quite simple. They operate off the existence of elements, such as h1, h2, h3, h4, and h5. These effectively denote the varying sizes of text that we can have on our web page, with h1 being the largest and h5 being the smallest, like so. Just make sure to add in their end vectors as well. And as a general rule of thumb, note that anything that you want to actually be able to see in the web page has to reside inside the body tags. The head tags are just for metadata. The sole exception being this title line here, which represents the text you see on the browser tabs. Okay, so let's actually test this out and see it in practice. Let's run our Rust project via cargo run. And check out our web page. One two seven dot 0.0.1:8080 slash profile page slash profilepage.html. And voila, we get a blank page. Well, it's at least better than a 404, web page not found, which would be the case if we ended our binary with Ctrl-C and tried again. Okay, so let's reboot our project and voila, we get back our blank page. Alright, so then what happens if we add in an element in the HTML of our client-side code and refresh like so? We get a visual back. The other H elements are quite similar in nature as such. Technically there is also the P element, but this one isn't as commonly used due to something we'll cover later in CSS. Now, if you ever want to organize your materials, you can group them using div elements, which also come in handy later if you ever want to create lines or shapes with CSS. Yes, but how do you stylize them using CSS? This is where ID and class come in. Essentially, you're naming these elements so that you can refer to them later in the CSS file as needed, like so. IDs are unique, meaning only one element can have the same ID at any one particular point in time. But classes can be reused, meaning the same class can be associated with any number of elements. Let's move on over to CSS. It's pretty straightforward. To refer to IDs, you start with the hashtag keyword followed by the name of the ID, then bracket. To refer to classes, you start with the dot keyword followed by the name of the class, then bracket. Okay, so I'm just going to quickly color this div so we can see it. Now let's start with sizing. You can always resize elements past their default settings via height and width like so. For actual text, we can change the size of text manually via font size. Now, if we use height/width for text elements, though the element itself will change as seen by the spacing here, the text inside won't be affected. Next up, we have positioning. You effectively have two options. Either use position absolute, which will allow you to move things away from the origin of the whole page via top, left, right, or bottom. Or you use position relative, which will allow you to move things away from where it would have been ordinarily, again via top, left, right, or bottom. That is, to move things away from the top, left, right, or bottom of where it ordinarily would have been, with pixels being used as a metric. Technically, there are some caveats regarding these, but CSS is usually easy enough to just Google. In case you're wondering how to make lines, one easy way is to just make either height or width very small. Thus, we can now add text, resize it however we want, move it wherever we want, create squares, resize it however we want, move it wherever we want, and make lines, resize it however we want, move it wherever we want. It is now time to start referring to JavaScript to bring in functionality. JavaScript is quite similar to CSS in terms of how you can link their endpoints with HTML. That is, inside the angle elements, we just add in a onClick equal function parentheses line, replacing function with the name of the function we want to call inside our JS files, like so. As seen here. The great thing about JavaScript is just like Rust, albeit with some syntax differences, as such. Okay, given this, we just have one last thing to cover. How do we actually initiate a post request from the client back to the server in JavaScript? Here's some more boilerplate. All you need to make sure is that the subvariables here match with the subvariables in the Rust struct inside of derive the serialize. And that the first parameter inside fetch parentheses matches the web page that the struct resides in. For cases where you want to process multiple types of post requests in the same web page, what I typically do is just add in another subvariable called operation, like so. And then use if statements inside the function that ultimately ends up being called back in server-side Rust as such. Technically, this last part is really only ever necessary if you intend on collecting data from users, in which case you will most likely need a database in order to store these dynamic data points, something we will cover later in our next session. But actually, we just forgot one thing. How to actually get that set data. Introducing elements, input and button. It's fairly straightforward. Users put in data in input, and then we use button to collect that data. More specifically, we add an on-click parentheses tag to our button. And then in that call JavaScript function, we reference the submitted data via document.getElementById, parentheses, quote, element name, quote, parentheses, dot value, dot trim, parentheses, semicolon. This then gives us a value inside of element name. It's also good practice to add cursor, colon, pointer, semicolon inside the CSS of that button's ID, just in order to indicate to the user that we can click on it. That's it. See you next class.